Well, when I bought it, it was 200 something, but I'm sure it's up to 400 something at Costco. Okay, tomorrow, do not forget,
no school.
You report to the lower gym at 7:20. If you're late, be prepared to get yelled at.
By who?
Doc, you know him.
Oh, Doc.
Me and him are fine.
Okay, let's see how close you are tomorrow morning. So we are going to discuss the second worksheet, and then the test is on Wednesday. Now, why are we taking this AMC test?
Because we want to see how creative a teacher you
Which comes, did you guys even start doing any practice problems?
I did.
Oh, we don't get it.
Okay, look, this is why we're doing it. I'll just go over it. AMC 12. Now, the way this test is graded, did you guys even look at that sheet?
I did.
Did you give it to us?
There's 20. Castration.
Did you give it to us?
Yeah, when you are absent, you are responsible for what happens in class.
See, it's not like me. Do you want to be perfect?
So I can assume you two didn't even try any problem.
I tried out.
Okay, now on the AMC 12, which you'll be taking tomorrow morning, you need number 2 pencils now.
Or soft lead.
Yes. Okay, there are 25 problems. Every time you get a problem correct, you will get 6 points.
Yeah. 6 points.
Every time you leave it blank, you get 1.5 points.
Wait, we get one for leaving stuff blank?
You get 37 and a half.
And if you get a problem wrong, you get 0. They changed the scoring several years ago because they used to give negative for a wrong answer. But then students were getting negative scores. And it's kind of discouraging, so they changed the scoring system. So now the lowest score you can get is 0 instead of negative whatever.
Negative 37 points.
Okay, so you can see the highest score you can get is 150. In the history of Hawaii, only one person ever got 150.
Who's that?
That was
Mr.
my
Park.
classmate from Castle High School. I had no idea how smart and math he was. Because we used to hang out with him like that, but we kind of seemed. I mean, he was smart, but we didn't think he was a genius. Because the smartest guy ever to go to Iolani in math, this guy called Jonathan Higa. I ever mentioned him?
Yeah.
He got 145.
Wait, Mr. Park, what'd you get on that?
When I was in high school?
Yeah.
I don't know, not good.
Wait, how many are
I was dumb in high school. Anyway, so your goal, okay, so this is going to count as a quiz. So this is, you can actually get bonus of it. Whatever your score is, I'm going to divide that by 5.
and round down?
And greatest integer, that rounds down, greatest integer. And that's going to be out of 20 for a quiz. So if you get 150, like if you're the smartest student in the state of Hawaii ever, then you can get a 30 out of 20. But if you get 100, then you get a 20 out of 20. Now, the reason why you want to score 100 or better,
Shrink 7.
because if you get 100 or better, you get invited to take the next level test, which is called the AIME.
Oh my god.
So tomorrow's test is 75 minutes, okay? Multiple choice. If you get 100 or better, you get invited to take the AIME, which is 15 problems, 3 hours.
I literally slept for 2 hours.
No, it's an honor to take this test. Plus, they'll give you a pin. You can go up to an honors day and get your pin.
2 problems.
Oh, I kind of want that.
Didn't
Yeah.
do anything else.
No, if you make it that far, you're among the elite. You're the mathematically
It
elite.
is multiple choice.
Now, shh. And then, if you do well on both of these tests, you get invited to take the USAMO test.
Was that Ethan Bo last year?
No, he took the junior one though, for juniors. Okay, so it's 7 problems, 7 hours.
Oh.
No, that's a mistake. It's 6 problems. 7
Oh,
The first 2 days. So the first day you're gonna be in Doc's office 3 hours. I mean 3.5 hours doing 3
Is that
problems.
like a
I was just
Go sleep already.
No, it's a proof. You gotta do a mathematical
Go
proof.
knock out already.
And then the next day you go back 3.5 hours. You work on 3 problems. And then based on this test, they select the top 25 students in the nation to go to math camp. the only one to make it to the math camp. And then from the
didn't
math
choose
camp, after you work with all the top mathematicians, in the nation, they select
Go to
the
the
top
Olympics.
5 to represent the United States at the International Mathematics Olympiad, where you challenge all the other countries. Usually Russia, China, Romania, those they're like.
Uganda.
I won.
So that's why you're taking this test. They want to identify students of exceptional mathematical ability.
And they take the top one person. and
But for you, it's going to be a quiz. Anyway, Jonathan Higa, he graduated in 1990 from Iolani.
That's old.
This is how smart he was. In 10th grade, he finished Calculus BC. He was the top student in 10th grade. And then in 11th and 12th, I guess he could have gone to UH and take classes there, but because of the schedule, he couldn't, so he just learned on his own. And then he went to Princeton University, he got his bachelor's in math and physics, and then he got his PhD in mathematics from UH, and then now he works for the National Security Agency.
Oh.
as
How are
a
you supposed to even
mathematician.
know that? That's national.
Well, you guys know why they hire mathematicians, right? Yeah, encryption. What's that? Okay, like for you
It's
guys,
1, 2,
okay,
3, 4,
what
5.
if you want to buy something on Amazon.com? You put in your credit card number, you send it. How do you know it's safe? How do you know nobody's going to intercept that and
Encrypted.
use your? Yeah, you encrypt it.
HTTPS.
Okay, but do you even know what our encryption system is based on?
No.
Prime numbers. It's called
All
RSA.
real.
It's RSA after the three, I don't even remember their names, after the 3 guys who invented this. But, okay, in order for this to work, you get 2 really large prime numbers. You gotta pick small kind, like 7 and 11, okay? You gotta pick really large prime numbers, like 200 digits each. That's why you know how these mathematicians are trying to find like the largest prime number like that? Because you use these large prime numbers for encryption. Anyway, you multiply these 2 prime numbers, and don't you get this gigantic number? The only way that the code can be cracked is if you can factor this large number into the 2 prime numbers. That's the only way you can break the encryption. Now, some of you might be thinking, oh, that's easy on a computer. Yeah, but a computer takes 10 to the 87 years to do that. For some reason, it's very difficult to factor large numbers. Like, it's easy, like if it's 77, oh, 7 times 11. But I'm talking about really large numbers, 300 to 400 digits long. A computer will take 10 to the 87 years. So, so you know what's happening now, right? All the bad guys, they're trying to devise some kind of computer program that can factor large numbers. Because once somebody figures out how to factor large numbers, then the encryption system we have today is not going to work anymore. You know what I'm talking about? So that's why the people at NSA, what do you think they're doing? They're working on a new encryption system, because once somebody figures that out, you can't use that anymore. Then you got to go to plan B. Yeah.
Wait, if they know that encryption, the guys that are working for that, why don't they just break it and just steal from everyone?
No, they can't. They can't factor it. The computer takes 10 to the 87 years.
But if they
Unless
created
somebody
it-
comes up with like an ingenious.
If they created it, they'll know how to crack it, right?
What?
It's
No.
because of computers.
That's because, yeah, it's very difficult to factor large numbers. Very, very difficult. Okay, anyway, just be there at 7:20 tomorrow. We're looking at your- Okay, this is the last chance to ask questions because the test is on Wednesday.
Wait, what are we doing in class tomorrow?
Free period. Pretty much. You already took a 75-minute test,
Yes!
right?
Free period.
Oh, yeah, I don't have it. Okay, you guys gonna have to read me the
We
problem.
don't have any questions.
We are, no questions, I see everything except B up there. Okay, A, somebody read me A. Integral, what? X, ln x, quantity squared,
Integration by
dx. Okay, now what are the 2 things you gotta know in this test? Integration by parts and exponential growth and decay, that's it. Which one do you think this is? Integration by parts. When you have integration by parts, either you gotta do it the regular way or you tabular, right? There's only two ways.
Tabular.
Okay, so the first thing you gotta ask yourself, can I do tabular?
Yes.
No. In order to tabular, you have to have a polynomial, so you can take the derivative down to 0. The other part gotta be able to be repeatedly integrated. Can we even integrate that one time?
Oh, I remember.
No, you cannot. So you have to do the regular way.
Wait, so you need to tell us what that is.
Okay, so what? Where do I put the ln x squared? Do I put it here or there? You have to put it here, because if you put it there, you gotta know the antiderivative. We don't know the antiderivative. Okay, now fill in the chart. Okay, this one is antiderivative. That's easy, 1/2 x squared. What about this? How do you take the derivative of box squared?
Box to the
2 box to the first times the derivative of box, which is 1/x dx. And of course, if you don't multiply by the derivative of box, it's just a fade already. Come on, we gotta.
UV minus V.
Okay, so this is equal to, I'm not gonna write the original problem, is equal to UV 1/2 x squared ln x squared minus the integral of v times du. Now, what happens when you multiply this times this?
The
The
twos
2's cancel out. This x cancels into one of those x's, and you get x ln x dx. And some of you are looking at you guys quiz. This x cancels into that, you know. Some of you are writing like x squared over x or something weird. Simplify. Okay, so this integral can only be done if you can do this integral. How do I do this integral right here?
Do it again.
You gotta do it again. So you put the chart. So what? Where do I put the x? You gotta put the ln x here again, because you don't know the antiderivative of ln x, although some of you think you do.
Yeah.
But you don't. So
And
what's the
did you
derivative
tell
of
us?
ln x? 1/x dx. So this, so box is equal to uv minus the integral of v times du. So that's a 1/2. This x cancels that x, and you just have x dx. So in order to do this, you got to be able to do that. Can you? Yes. So minus 1/2 times, what's the antiderivative of x? 1/2 x squared. So this becomes 1/4 x squared plus c. So this is what the box is equal to. Then you plug it in here. And see, this is where students make mistakes. You see this negative sign? You got to distribute it in there. So this negative sign got to be distributed over there. So your final answer is going to be 1/2 x squared ln x squared minus 1/2 x squared ln x plus 1/4 x squared plus c. I thought you said you got to distribute. Shouldn't that be minus c?
Yes.
Yeah, well, if you put minus c, that's still correct, but that's just mathematically gauche. A constant
gauche?
multiplied by -1 is still a constant, so we just call it c. You just gotta get used to that.
Wait, so that's what the sheep's goes to.
Okay, next, b. No, b is not up there. C. Somebody read me c. Integral.
Let's go to MATCAP. I want to go to MATCAP.
Oh, I like this. Oh, I can tell. I can see what's gonna happen. What? X is greater than 1. Why do I put that restriction? Because an absolute value is gonna pop up somewhere. Yeah.
You suck.
Okay. No, we're doing integration by parts. Can you see that you cannot do tabular? Because otherwise you have to be able to repeatedly integrate that. You can't even do it once. So that means you have to put the sign inverse here, because we don't know the antiderivative. And this is the x dx, which makes this 1/2 x squared. What goes here? What's the derivative of sine inverse box? Some of you still didn't have your derivatives down.
Natural.
No. 1 over square root 1 minus box squared
1/x squared.
times the derivative of box, which is -1/x squared dx. Some of you used to go forget the dx on the test. -1. You know what? Maybe I should take off -2.
No, no, thank you. We're good.
You guys don't put the dx's in the plus c's.
We're good.
It'll make you pay for it.
How about minus-
Okay, so this integral, the original one, is equal to
Minus
uv minus the integral of v times du. Now, what happens when you multiply this times this? This -1/2 can be thrown on the outside. This x squared cancels with that x squared, right? So all you have left is dx over root 1 minus 1/x squared. So now, how do I, this problem hinges on whether I can do that integral.
Sine is.
See how I circle it? So that at the end, I distribute the 1/2. Because some of you, I remember the last quiz, you guys are forgetting that number there. That number has to be distributed. How do I do that integral? You gotta simplify it first. How do I simplify this? Inside the radical, make a least common denominator. What goes on the top?
1
So x squared minus 1.
Oh, that's not inverse. No, it's not.
Oh. And the x squared comes out of the radical as?
What are we at? Or x. X.
No, absolute value of x. I keep telling you guys,
Square
the
root of x.
square root of x squared is not x, it's not plus or minus x, it's the absolute value of x. However, since x is great, it's positive, you don't need the absolute value. Plus we're AB, right? And then of course, when you divide by a fraction, that's like multiplying by the reciprocal, so that becomes x dx over root x squared minus 1. Are you guys, would you guys even be able to get that far?
No.
Take the minus 6 already. Okay, so how do I do this integral?
Give up.
U substitution. Class, what should I let you? You guys should be experts at spotting U substitution already. X squared minus 1 du
2x.
equals 2x dx. Is that going to work?
Yeah.
Yeah, because look, x dx is going to work. So you get radical u in the bottom, and x dx is equal to du over 2, not times 2, over 2. And hey, I know how to do that. That's like u to the negative half, so you make the power 1 bigger, put the reciprocal in the front, but these cancel out. So all you have left is radical u. But you resubstitute back in, so you get this. So substituting back in there, here, you guys do that. Take this answer, put it in here, and then put the plus c. You guys can do that, right? Don't forget the plus c. Next, D. Integral, Huang. Okay, this is the one we had in the book. Remember I told you it's tricky? Now, on the test, you're going to have one problem like this on the test. I'll do this. Should I do this? Tricky. Tricky. What do you want me to put to signify that this is the one?
U equals root x.
No, I'm not going to tell you what to let u equal.
Oh, wait.
This is the one you have to make a u substitution first. Remember we did it? We did it on the homework, or I copied it down, I think. And then
It's problem D.
we did it on the first worksheet, and now we got the second try.
Yeah,
You can just keep copying and see what happens, yeah? U
Copy-
equal
copy there is
cosine
best.
root x. Du equal, no, just root x full.
That's what I was saying.
1 over 2 root x. Some of us still don't even know the derivative of root x. We still don't have that memorized. Just like you probably don't even know the capital of Maine is Augusta. Root
Still?
cosine u, gosh, that's this. What do I substitute for dx though? 2 root x du. Right, if you move it on this side of the equation. Well, but Mr. Park, if I'm doing du, everything got to be u's. Well, what do I substitute for this? Right there, u. So here, let me write it in a nice way. 2u cosine u du. And then you should recognize that. What are you thinking in your head? Tabular. This one you can do tabular. So 2u, you take the derivative down to 0. This column, you take anti-derivatives.
Tick,
Tick, tack, toe. So your answer is going to be 2u sine u plus 2 cosine u. Even Pancho learned how to do this. Plus
Poncho's
c.
the dumbest.
Well, in that movie. But it, never mind. And then final step, resubstitute that back in. You guys take that last step. Resubstitute the root back x back into the. Hey, that's just like the one we did on the first worksheet.
It's the exact same one.
No, it's not exact. No? Question?
Can you do the, I don't get how you put it back into terms of u.
It's like a stab in the back.
So once you find du,
Okay, you have to substitute for this. This is cosine u, right?
okay.
Then you have to substitute for dx. Look, what is dx equal to? How do I move this on this side of the equation?
Times by 2 root x.
Okay, so isn't dx equal to 2 root x du? That's what this is right there.
Okay, and then just you have to substitute.
And then root x is equal to u right here. So that's why it's true. If I make you leave, you're gonna have to come after school to make up the time you missed. Okay, next, df. Right? Okay, don't have one of these on the test. Which one is this? When you have like an exponential and then either sine or cosine that? This is the solving for the unknown integral. Go ahead, have one. Only one, that's all. Just prove to me you can do it one. Okay, so u equals, so you gotta do integration by parts. So keep it consistent now.
Wait, Mr. Park, it doesn't matter which side you do for which, right? As long as you stay consistent.
Isn't that what I just said?
Yes.
Yeah, you can switch these too, but fine, but on the next step, then you gotta make sure you put the trig function as u and the exponential as dv. Why don't you just do it this way all the time? In fact, some of you, if you've been doing it on your own, you guys start recognizing patterns, yeah? Did you guys recognize the pattern? Of course not.
It's always
Okay,
over
fill in the
13.
e to the box is e to the box times the derivative of
always
box.
over
And then the
13.
antiderivative of this will be 1/2 sine 2x. Some of us still getting the derivatives and the antiderivatives mixed up. Then have trouble. Okay, so oval, the thing that you're trying to find is equal to uv.
For cash.
That's it.
Nicole.
No.
uv minus the integral of v du. So when you multiply this times this, you get a negative half. So throw that in the front, and you get e to the negative x sine 2x dx. Okay, then this is the box. See, this is where some of you made the mistake. You didn't distribute this 1/2 in there. So u equal du. So you got to do another integration by parts. Stay consistent. If you make the exponential u, you got to make the exponential u here also. So e to the box times the derivative of box, and then over here, negative 1/2 cosine 2x. So box is equal to uv. You just gotta keep track of stuff. Minus the integral of this times this. The 1/2 gets thrown on the outside, and you get e to the negative x cosine 2x
So we
dx.
make it positive.
Okay, so let's see what we got. Go back to the beginning now. Oval is equal to 1/2 e to the negative x sine 2x plus 1/2 times the box. So this is the box. You gotta take that 1/2 and distribute it over here. So you're gonna have minus 1/4 e to the negative x cosine 2x minus 1/4 oval, because that's oval. So in order to solve for oval, you gotta bring all the ovals on one side. So if you bring this on this side, it's gonna become, what's 1 oval plus 1/4 oval? 5/4 oval. I can't believe we're getting this on video. You know if any other teachers should see that I'm doing box and oval, I'll be laughed out of the dorms.
Wait, the teachers have dorms?
Yes, when we grade AP exam, you stay in the dorms.
Really?
Huh?
What dorms?
Well, when I did it, was at Colorado State. So I was in the dorm. Okay, so how do I solve for the oval? Multiply both sides by 4/5. So if I multiply this by 4/5, you can get 2/5 e to the negative x sine 2x. Multiply that by 4/5, the 4's cancel out, and you get
1/5.
1/5 e to the negative x cosine 2x, and then put the plus c.
Oh, that's right.
It's not difficult, people. It's just, it's very mechanical. Now, did anybody notice a pattern?
The first term is always twice the second term. The constant.
No, because the quiz that we had, didn't I put 3 and 4, or was it 2 and 3? I forget it. 2 and 3, so on the test, 3 and 4 then.
Yeah.
But since I told you that, 4 and 5. It doesn't matter, okay.
The bottom thing is.
It
the
doesn't
first
matter.
thing
Okay,
plus the
let's
second
call
thing
that
squared.
A, and let's call this B. If you have A and B here, these
A
coefficients,
squared
do
plus
you
B
guys,
squared.
look, you see this coefficient right here?
A squared plus B squared.
Exactly. It's a squared plus b squared.
Okay.
So whatever the numbers are, this did, I don't know why I'm telling you this. If I tell you this, you guys better actually use it then.
Wait, what?
And C, shrink 2.
This is A. A is the coefficient of x on the exponential thing. B is the coefficient of x on the trig, either the sine or the cosine function. This denominator here will always be a squared plus b squared. Always. So in this case, a is -1 and b is 2, right? What is a squared plus b squared? 5. So if you don't get 5 in the denominator there, you did something wrong. That's like a check.
No, that's
I'm not talking about the person from Czech Republic.
Racist.
So like on the quiz, okay, what was the one on the quiz? Somebody read it to me. E to the 2x, sine or cosine? Sine 3x. Okay, this is A, this is B. What is a squared plus b squared? What is a squared plus b squared? 13. So if you don't have 13 in the denominator, you did something wrong. You know what I'm talking about? Yeah.
Is there a trick to get the top number?
It's a while ago, huh?
Yeah.
Oh, you suck? Oh, it's just
Yeah, well, but you don't know where it goes and whether it's plus or minus though, see that's the thing. So, no sense. You guys are already struggling with this a squared plus b squared thing already.
Also, Garen's is going to be e to something times trig.
Yes!
Sound good.
You're AB, that's all we can handle.
What's the translate?
Okay, G, y,
Wait, we're not
integral. I can't believe we have to actually go over that.
Secant inverse radical x.
Oh, your voice came low.
What?
What?
Oh, there's limits!
Oh, she's.
I believe we did this on the homework. You made me do it on the board.
We did. We don't need that.
We're going to do it again.
Yeah, we're gonna do it again. Okay, we're gonna just, you know what, I'm gonna put it again, just to see if you can do it. Okay, so what, can I do tabular? Don't be ridiculous.
One-way tabular.
Integrate
Secant inverse root x dx.
Sorry, tabular with 1.
Okay, let me see if you can even find the derivative correctly. Lynn, redeem yourself.
1 over
Actually, that makes sense.
radical, no, absolute value of x. Root x, fine, x squared minus
What? What?
It's both his work.
Root?
that's x.
Root?
X squared.
No.
X minus 1.
Times,
Derivative over x.
which is 1 over 2 root x dx. You guys see that? Well, of course, if you don't know the derivative of secant inverse box, this just looks weird, right? It's 1 over the absolute value of box. Where's the absolute value, Mr. Park?
It's
Square root is
positive.
always positive. You don't need the absolute value.
How about plugging in one?
Square root of box squared minus 1 times the derivative of box. There you go. Okay, so this is equal to uv minus the integral of d du. Now look, what happens when you multiply d times du? Radical x times radical x is x. That cancels that x. So all you have left is a 1/2 on the outside and a dx over root x minus 1. That's all. Everybody knows root x times root x is x, right? Okay, is that integral doable? Do I have to do u substitution?
Yes.
No! What's gonna happen on the AP exam, people?
We're gonna have some fun.
This is like x minus 1 to the -1/2 power, right?
Oh,
Can
the
I
half
just
cancel.
make the power 1 bigger and put the reciprocal in the front?
Yeah.
Yes, because the derivative of the box is 1. How do you adjust for 1? You put a 1 in front. Do I need to put the plus c?
Yes.
No, because we have limits of integration from 1 to 4. The plus c's are going to cancel out.
Bless
And
you.
so do the 1/2 and the 2.
God bless you.
Shh. Okay, plug in the top number. 4. I seem to remember doing this in the homework. Secant inverse 2. Hey, it's the same thing from the homework. Minus, plug in 4 here. 4 minus 1 is 3 to the 1/2. Oh, it's exactly the same as the part. Plug in 1. What is secant inverse 1?
0.
0. And then 1 minus 1 is 0. Hey, that's the same two terms that came out 0 on the homework too, Mr. Park. You know what? We'll put this on the test. I'm just gonna change the limit. If anybody gets it wrong, we'll pick up double.
1 to 1.
You know what this is? This is telling me that you just copied down the homework problem and you don't even know you even copied it down. That's what it's telling me.
Well, that's assuming we copied it down.
H, Hoang, integral
Limit
0
0 to 5.
to 5. Are you sure, Kimo? That's not what I got, Kimo. No way, that's a stab in the back. Okay, continue.
X squared. Sine squared x.
Sine squared x dx.
Okay, this was on the homework too.
It's like a black bag.
Can you do calculus?
There.
Yes, you can do calculus. Shh. X squared can be taken down to 0, right? Now, can you repeatedly integrate this? Yes, because the only way you can integrate sine squared x is by using the identity. That's the identity, that's not the integral now. And then can this be repeatedly integrated? Yes. Okay, first one. Suzaki.
1/4 x squared.
No.
What?
No.
What you talking about?
What's the integral of this?
Yeah, baby.
This is just 1/2.
Oh, 0? Wait,
It's just 0.
Half x minus
Okay, so here, second check. 1/2.
x minus 1/4 2x.
Okay. Then you do another antiderivative. Brendan.
1/4 x squared minus or plus 1/8 cosine 2x.
Okay, and then one more time. Put your head down. Yamane.
1/8.
Am I going to be there going?
Oh, 1/12.
Hey, wait! I remember calling on you on that same problem. You did the same mistake.
No, that's a
Go.
different person. That was a different person.
That was Tommy.
Okay, continue.
1/12 x to the
Ratting up the Brennan.
plus.
In unison.
Oh, you guys think alike then?
Yeah.
Is that it? Okay, and then one.
16 sine squared.
Very good. And then now, tic, tac, toe.
Hey, that actually works.
B, 5, oh.
Oh yeah.
Okay, so here. Oh gosh. This times positive 1.
What were we supposed to
You guys supposed to know how to do this. So if I take the x squared and multiply it there, you're going to have 1/2 x cubed minus x squared over 4 sine 2x. Then the next term is going to be this times -1. So take a negative 2x and distribute it, so you're going to get
Negative 1/2.
negative 1/2
X
x
cubed.
cubed minus
1/4.
1/4 x cosine 2x. And then this times positive 1, so basically just distribute the 2 there. Plus 1/6 x cubed plus 1/8 sine 2x from 0 to pi.
That's too hard.
And if you want to simplify, you can, but I would say don't simplify.
Cancel out the
Just
half
plug
x
in the
squares.
pi's and the zeros. Half of them will be 0, right? Because sine of pi is 0. Sine of 2 pi is 0. Sine of 0 is 0. Lots of it's all zeros, man. Except the ones that are not. You guys, if you cannot plug in 0 and pi, then
Go home, cook.
yeah.
Okay, we done?
Well, that's all I see. So no other questions. So the next time I'm gonna, well, I'll see you tomorrow. But
So we show up to class, but we're not gonna do anything.
well, maybe we will.
We sit free.
March 10th in delivery.
Second time through.
Well, usually the students say that's inspiring, but then I don't know. It didn't seem like you guys got inspired. Maybe we gotta do that. Stand against the wall, make the snake. And I go down the line drilling you. What's the derivative of tan x dx? Couldn't even answer that one. Negative natural, no, that's derivative.
Negative natural log cosine
Negative-
f. Absolute value
value.
cosine x plus c.
Yeah, and if you don't say that, you go to the back of the line like the, what's her name? Escobar. What's her name?
That's racist.
Yes, for the derivative.
I said derivative? No, I didn't. Check the camera. Sit down. Okay, if it's derivative, then it's secant squared x. Okay, the bell's gonna ring in 5 minutes. Hey, some of you better kick it up a notch. If you don't know how to do this chapter, the next chapter is just all misery, because we're gonna use integrals to solve problems. And if you don't know your integrals, what's gonna happen? Hey, wait. And are some of you in like a hole after that first test?
Wait, you're okay though, right?
Let me look. Yes. We need to dig our way out of this hole.